Hello everyone, so in this video we're going to go ahead and use the electronegativities of the atoms to determine the direction of the dipole moment in the indicated bonds. So the ability of an atom to attract the shared pair of electrons towards itself is what we call electronegativity. The dipole moments occur in bonds as a result of differences in electronegativities of the bonded atoms. The difference in electronegativities result in the separation of charge, creating what we call a dipole moment. The more electronegative atoms have a partial negative charge, while the less electronegative atoms develop a partial positive charge. The direction of our dipole arrow is from positive over to negative. So starting off with our first molecule, which we will redraw, and we can do everything from structure A in this purple color. Again, we're redrawing the structure out, so we have a carbon with 3 hydrogens connected to it, and of course a chlorine molecule with 3 lone pairs. Alright, so again for our first molecule, chlorine has an electronegativity value of 3.0, which again we'll write this out. So chlorine has this value of 3.0, and carbon has a value of 2.5. So these electronegativity values can either be found in your textbook, given to you by a professor, or even found online. So these are values that I'm using here. Again, chlorine has a value of 3.0 and carbon has a value of 2.5, making our chlorine atom more electronegative. So the dipole is going to be from our partial positive carbon atom, which you can represent by a lowercase delta and plus symbol. And then our chlorine is going to be delta minus, and the arrow is going to be pointing towards our partial negative chlorine. So it's going this way here in red. And our second molecule here, which we'll go ahead and redraw again, we can do all of this in a blue color. So again, we have this terminal CH3 group, so carbon with 3 hydrogen groups, and then a magnesium group at the end. All right, so for our electronegativity values this time, again, carbon has a 2.5 value, and magnesium here has a value of 1.2. So we can see here that carbon is going to be the more electronegative atom here. That's going to be a delta minus. And of course, magnesium by default will get this delta plus our partial positive charge. So for our dipole moment this time, it's going to be towards our partial positive magnesium atom to the partial negative carbon. This is going to go ahead and go this way this time. Alright, so again, in this problem we're being asked to use our electronegativities of the atoms that we have written over here to determine the direction of the dipole moment and the indicated bonds. So go ahead and highlight those dipole arrows or dipole moments in our indicated bonds.